Hello children, welcome back to my YouTube channel, and today I'm going to discuss the acid-base reactions with you. So simply neutralization reactions. I'll discuss the concept first and then we'll move into the practical session. And I request you, if you haven't subscribed my YouTube channel, subscribe it first and stay tuned with my YouTube channel. So let's move to the concept and then we'll come back to our practical class. So let's move to the theory behind acid-base titrations. Acid-base titrations are usually used to find the amount of a known acid or acidic or basic substance through acid-base titration. You know, acid is a substance which can release H plus ions to the medium. Acids can release H plus ions to the medium, and bases usually release OH minus ions to the medium. So, if you have an acid and a base, and if you don't know the real concentration of acid, this is the unknown one. If so, you should have a base with a known concentration. You can use these two solutions to a titration, and after you titrate the acid with base, then you will be able to do a calculation and find the concentration of the acid. So simply, this is the setup. This one is the setup for the titration. You're having a burette and a conical flask is there. So you have to perform the titration. You can see the content inside the conical flask is having some color. Usually we are using an indicator because at the end point you will be able to identify a color change in the presence of an indicator. So you have to put that indicator to the content in the solution in a conical flask. And the other thing is we use a burette to add the substance which is having a known concentration. And you should put the substance where this is burette should contain the solution with known concentration. And you have to put the solution with unknown concentration into the conical flask. And remember, the unknown solution or unknown concentration of the solution can be calculated by using the content that you have discarded into the conical flask from the burette till you get a color change at the end point. The place where you observe a color change is called the end point. And the solution that you put into this conical flask should have a known volume or known amount. You should know the exact volume of this one, right? Known volume is there or known amount is there, but you don't know the concentration. Here, you know the concentration. Usually, the volume or the amount that you add to the burette depends on the milliliters calibrated on the burette. There are several sizes of burette. So usually we are selecting 50 milliliter burettes for our general titrations. Then here you can see the main equipments used for the titration. The first one is burette, and the second one is a set of pipettes I have given. They may contain different volumes like 10 milliliter, 25, 50 milliliter. So usually we use around 20 or 10 cubic centimeter of the unknown solution or the solution with unknown concentration to the conical flask. I told you the content inside the conical flask should be with known volume or known amount. and you have to use a pipette filler. And the last diagram, the diagram given in here, is a conical flask. This is a conical flask, and those are pipettes. This is a burette or the burette. Then the analyte is a solution with an unknown molarity or concentration. So here titrant, we call that one as titrant. Now I told you, if this is a burette, you have to put the solution which has known concentration to the burette, and you have to put the solution with unknown concentration to the conical flask. Here, the solution that we add to the conical flask is known as titrant. The solution or the reagent that is which is a solution with a known molarity or a concentration that will react with the analyte. Analyte means the solution in the conical flask. This solution is known as titrant. Titrant. So you can see that. You can easily remember that T, this titrant ends with T. So that means that is there in the top. And titrant ends with down, D. So you can keep it in your mind as down, D down. Titrant and titrant. Then let's move to the practical session, how to perform an acid-base titration practically. Here you can see I have added unknown solution, that is acid, to the conical flask using a pipette. Now I am going to set up the burette to the burette holder. So you have to clamp the burette tightly into the burette holder. And then you can use a funnel to pour the content or the solution with known concentration into this burette. This is the way that you have to add the solution into the burette using a funnel. Then you have to fill the burette little more than the 0th level of the top. And then you need to discard some solution to a beaker like this so that you can remove the air bubbles inside. There may be some air bubbles trapped near the tap of the burette. So you need to first remove them and then you have to start the titration. Then you can see I kept my conical flask below the burette, and now I'm going to add the phenolphthalein indicator. So as you are having an acid in the conical flask, you will see what is the color in the presence of an acid of indicator. So we'll see. I'll use a dropper and add few drops of phenolphthalein to the conical flask. In here I have 10 cubic centimeter of unknown acid, or the acid with unknown concentration in here. So now I'm going to add some indicator there. And then you can see there's no any color, so you can understand phenolphthalein is colorless in acidic medium. Close the phenolphthalein bottle well, because that is dissolved in ethanol. It can easily evaporate out. So first make sure to close it and then continue the titration. Now you can use the tap to add the solution in the burette dropwise. So you have to have a control in your hand when you do the titration. So here you can see I use one hand to mix the content in the conical flask, and the other hand is used to control the tap of the burette. So you have to make sure to which direction you have to open the tap and close the tap. You have to pay your attention carefully. And yeah, I'm adding the solution dropwise. You can see when each drop is contacted with the solution in the conical flask, you have to make sure that you're mixing. So you have to continue this till you get a light pink color area in the middle of the conical flask. Now you can see when the solution is in contact with the solution of the conical flask, they start to give a pink color. But when you mix, it disappears. So this is an indication where it's very close to the endpoint. Now you can see it has reached the endpoint because you observed a color change. So make sure to control the tap when you feel like you are very close to the endpoint, and you better stop the reaction even before this color. I mean, you better take a very light pink color. As I have added more indicator, this is bit darker, so you can observe how the color changes from colorless to pink color in a titration. You have to now take the final reading of the burette. Initial reading was 0 because I mark up till 0. You can use a dark color paper if you can't identify it clearly. So you have to deduct 25 from 0 and get the final reading. If you are looking for a class for London O-Levels or A-Levels in Edexcel, Cambridge, OCR or AQA curriculum, I'm conducting classes for the students all around the world, so you can contact me to the WhatsApp number given in the screen. So let's meet in another video, and thank you for watching.